how these Earth's features are formed? One of the many reasons we see the Himalayas, Mount Pinatubo, the Red Sea, and many more is because of plate tectonics. The idea that continents can move was proposed by Alfred Wegener in 1915 on the basis of the apparent fit of the continents, fossil evidence, rock and mountain correlation, and paleoclimate data. In 1962, geologist and oceanographer Harry Hess proposed his theory of seafloor spreading, which offered a compelling driving mechanism for Wegener's continental drift, but it needed more proof. Now, on the year 1968, Brian Isaacs, Jack Oliver, and Lane Sykes proposed the theory of plate tectonics, describing the motion of the plates which began on the Earth some 3 to 4 billion years ago, when the planet was still young and hot, but old enough for its outer shell to be cold. Now, let's take a look at the inside of the Earth. Based on the Earth's composition, our planet is divided into crust, or the surface of the Earth, the upper and lower mantles, and outer core and inner core. However, when we consider the motions involving the Earth, we have the lithosphere, asthenosphere, mesosphere, outer core, and inner core. The lithosphere is composed of the crust and a rigid upper mantle, while the asthenosphere is the molten upper mantle. Mesosphere, on the other hand, is composed mainly of the lower mantle.
Now, what happens at the surface of the Earth when the plates move? To simulate this, we will use cookies. The upper cookie is the lithosphere, the cream is the asthenosphere, and the lower cookie is the lower mantle. So how do plates move? The plate slides above the liquid asthenosphere. We have different types of plate boundaries, and movement on each creates land or sea features. First, the divergent boundaries, where plates move apart, resulting in an upwelling of material from the mantle to create new seafloor. Ridges are formed when plates diverge underwater, and rift valleys when they diverge on land. Famous examples of these are the Mid-Atlantic Ridge at Iceland, the Great Rift Valley, the Red Sea Rift between two spreading African and Arabian plates, and the Sinai Triple Junction. Second, the convergent boundaries, where plates move towards each other, resulting in the subduction of a basaltic oceanic lithosphere into the mantle. This subduction happens underwater and usually creates trenches, and examples of which are the Mariana and Manila Trenches. On land, however, conversions of continental plates creates uplifts, usually mountain ranges such as the Himalayas between the Eurasian and Indian plates, and Mount Pinatubo between Eurasian and Philippine plates. Volcanoes are usually created from converging plates, and the most destructive earthquakes in the subduction zone. Lastly, transform fault or strike-slip fault, where plates grind past each other without the production or destruction of lithosphere. This kind of boundary does not create so much dramatic forms or topography, and usually just folds or crumples along the fault line. Famous examples of transform fault are the San Andreas Fault Zone in Central California and the Marikina Valley Fault System, composed of the West Valley Fault and East Valley Fault here in the Philippines.
That's it, and I hope you learned a lot from this video. This has been Althea Go for Geol Ed series. Bye!